I'm going to go over section 3.5, the Pythagorean theorem proof, with you today. So when we do this, we're going to prove the Pythagorean theorem is always true. And so in doing this, we're going to construct viable arguments and critique the reasoning of others. So first of all, we need to know, what is a proof? What is a mathematical proof? It is a deductive argument for a mathematical statement. So what exactly does that mean? It means that using only the information that you know is true, you can make an argument that a different mathematical statement, like the Pythagorean theorem, is true. So you can take any information that is already proven to be true, that is a known fact or definitions, and you can build all that up to show something new is true. One thing you need to be careful of is in math, you cannot assume anything is true. It must always be proven. So whenever there's something new that comes up in math, it has to be proven before it can be assumed that it's true. Okay, so just a quick example of this is I'm going to prove to you that homework is important. So this is something that I can't just assume homework's important. I can't assume you like it, that you don't like it, but I can use some facts to show you that it is indeed important. Okay, there's different case studies and different research that's been done that shows that doing homework outside of class, doing those extra practice problems, really does make a difference in you learning and understanding the material. And so if you do that extra practice outside of class, then not only does it help you immediately learn the information, but years down the road, when you look back at it, you're more likely to remember it. Also, it helps you in other ways other than just your schoolwork. It helps you become better time management, and it helps you be more responsible, different things like that. It does make a difference, and there's actual research to show it. Okay, so that's an example of how you have to use strictly facts, strictly information that has already been looked at, has already been researched and shown that it's true, in order to show something new, like homework being important. So what is the Pythagorean theorem? We kind of also need to know that before we can prove it. The Pythagorean theorem is a squared plus b squared equals c squared. It's this equation here when a and b are the side lengths of a right triangle, they're the legs, and c is the hypotenuse. So if we have a right triangle, a and b are the two side lengths, they meet at the 90-degree angle, and c is the hypotenuse. It's the longest side. It's the side that's always opposite from the 90-degree angle. Okay, so we know what a proof is, we know what the Pythagorean theorem is. Now we just need to figure out how we're going to prove this. So let's start with a right triangle. We have a right triangle there with a and b as our legs and c as our hypotenuse. And then we're going to use that right triangle to create a square. So we're taking that triangle and we're rotating it and moving it around, and eventually we get this big square with that little square in the middle. So our goal is, when we're looking at this square over to the right, our goal is to say that the area of the four triangles plus the area of the small square is equal to the area of the whole square. We're saying all the parts add up to be equal to the whole thing. So as we go through this, that's what we're trying to get to, and then we can use that to get a squared plus b squared equals c squared. So let's go ahead and work this out. First of all, what's the area of the whole square? Well, area of a square is length times width. The length is c, the width is c, so c times c is equal to c squared. So what's the area of one triangle? Once again, we need to think about our formula for area of a triangle, which is 1/2 base times height. Base and height in this formula have to be the two sides that meet up at the 90-degree angle. Okay, it's never the hypotenuse. It's always the two legs, the A and B. So the area of one triangle is 1/2 base times height. Base and height are A and B. So my area is 1/2 A times B. Okay, so I know the area of one triangle, but I want to know the area of all four triangles. So I can take the area of one triangle, multiply it by 4, and that'll tell me the area of all four of those triangles in that square. So I'm going to take 4 times 1/2 AB, and then I can simplify that. I can take 4 times 1/2, which is 2, and get that equal to 2AB. I can't do anything else with my A and my B because those are variables and I don't know what numbers they are. So we're just going to leave them just like that. So now we need to think about what the area of the inner square is. So if we look at that, we don't actually know the length of the side of that square. We can see that it is part of the side of a triangle. It's part of that side B. But before you can figure out what that is, you need to notice that it's not part of the A. So if you take the whole side B and you take away that A that's connected to it from the other triangle, you're left with B minus A, and that's the side length. So the area of the small square is equal to the side times the side, which is B minus A times B minus A. Now this is the part where we have to do that double distribution. So I have 2 things in my first parentheses and I have 2 things in my second parentheses. I need to distribute every part of my first parenthesis to my second parenthesis, and then it needs to go to every part of that second parenthesis. So I'm going to start with the first B, and I'm going to multiply it by B, and then I'll multiply it by negative A. So B times B is B squared. B times negative A is negative BA, or negative AB. It's the same thing because multiplication is commutative. So since I've now multiplied that B to both parts of the second parenthesis, so now I'm going to multiply the negative A. So I have negative A times B, which is negative AB, and negative A times negative A, which is a positive A squared. So now I have that multiplied out, and I can simplify it. I have a negative BA and a negative AB. Notice that that's the same as negative AB and a negative AB. So this could actually simplify to B squared minus 2AB. So I combined my negative AB and negative AB to get negative 2AB. And then I have that plus A squared at the end. So now I have all the parts that I needed when we talked about our goal for this proof. We said that we needed the area of the whole square, the area of 4 triangles, and the area of that inside square. So let's go ahead and put this all together. We said the area of the 4 triangles plus the area of the small square is equal to the area of the big square. So I'm just going to put my numbers in there. My 4 triangles is 2AB. My area of my small square is B squared minus 2AB plus A squared. And that's equal to the area of my big square, which is C squared. I have a 2AB and a negative 2AB, so those cancel out because they're inverses. So when I make my copies, I get B squared plus A squared equals C squared. And because addition is commutative, I can write this in a different order. So I can write A squared plus B squared equals C squared. And that is my Pythagorean theorem. So what we just did was we took this square over to the side, this figure, and we found the areas of all the different parts of that figure, which that's something we know how to do. We know how to find the areas. and we worked it all the way down until we got a squared plus b squared equals c squared. That's it. Go ahead and try that out on your own. Try to finish it up without looking at your notes. And if you need more help, definitely come in and ask.